Hello everyone, today we'll be solving the problem Valera and queries, right? So this was asked in the Codeforces round 216, nothing but division 2 for the division 2, right? So here you can just go through the question. I'll just summarize the question so that it will be easier for us to understand, right? So what the question states here, just give me a second, 1 second. So the question states, let's see what the question states here. So Valera has n segments, right? So Valera has n segments. The guy named Valera has n segments on the x-axis. So n segments on the x-axis, right? So just keep this in mind. And he wants to answer the m queries. He wants to answer what he wants to answer m queries, right? So m queries. So I'll just give here queries. Let me write this one entirely, right? So uh, Valera has n segments on the x-axis and he wants to answer m queries. So each query gives a list of points. Just keep this in mind. Each query gives a list of points and we must count how many segments contain at least one of those points. Each query gives a list of points and we must count how many segments contain at least one of those points. That's what we need to find, right? So accordingly with the question, what we need to find, each query gives a list of points. So this problem is completely based on the query, right? So queries, right? So each query gives a list of points and we must count how many segments contain at least one of those points, right? How many segments contain at least one of those points. So a segment, so here a segment L comma R, nothing but the left comma right, contains point X. This contains point X if if only condition is L is less than or equal to X and X is less than or equal to R. So we can just write it in this way. L is less than or equal to X and X is less than or equal to R. Just keep this in mind. A segment L comma R, nothing but left comma right, contains point X if left L, this one less than or equal to X and X is less than or equal to R, nothing but right. So this is fine. What we need to output? We need to output the count of such segments for every query. What we need to output again? We need to output the count of such segments for every query. So constraints we have been given n comma m less than or equal to 3e5, right? 3 into 10 to the power of 5. Basically, n comma m constraints what we have given, n comma m less than or equal to 3e5 or 3 into 10 to the power of 5, right? Just keep this in mind. And total query points is less than or equal to 3e5 as well. Total query points are less than or equal to 3 e5. So here again, so this part is completely, I hope this part is completely clear. This is what the main part is actually, right? This one I'm speaking of, where it is this point until here. So this one, a segment L comma R contains point X, point, a segment L comma R contains point X only if L is less than or equal to X and X is less than or equal to R, and we need to output the count of such segments for every query. So again, let me read the question loudly. Just listen to this one more time. So Valera has n segments. So this one, I'm starting from the this one beginning. So Valera has n segments on the x-axis and wants to answer m queries, and he wants to answer m queries. So each query gives a list of points and we must count how many segments contain at least one of those points, right? So that's what we need to do. So again, this one is fine, I think. A segment L comma R contains point X if L is less than or equal to X and X is less than or equal to R. So we need to output the count of such segments for every query. So this is fine. This part, I hope this part is completely clear, man. Constraints, we have already went through the constraints. This one, n comma m less than or equal to 3e5, and also total query points has to be less than or equal to 3e5 as well, right? So let me delete this one entirely. So let me go with a step-by-step approach. Let me go with a step-by-step approach, right? So here, let's go with the first example here. Let me go with the first example, or let's consider the first example, right? So just let's consider input output pattern. So how we got the answer and other stuff, what data structure we'll be using. So that we'll be discussing in the approach, right? So here, see this. What shall I say? Just give me a second here. This 1 3 4 5 and this one 6 7. We have three. This one three queries, right? So here, uh, basically we have been given three queries and three segments. That's what 3 and 3 indicates here, right? So that's what 3 and 3 indicates here. So this part, so just give me a second, 1 second here. The input output part, first line 3 3, this is nothing but, first 3 is nothing but the segments, and the second, the 3 is nothing but the queries. Second 3 is nothing but the queries, right? So here segments we have got 1 comma 3, the first one, this one, the second one, this one is the first one, this one is the second one, this one is the third one, right? First segment 1 comma 3, second segment 4 comma 5, and third segment 6 comma 7. And what about this one, queries? Query, we have this one, what do we call, three numbers. First number 3 indicates that we have three numbers, nothing but 147. So first query is 147, and the second query, first two indicates that we have two numbers, nothing but 4 5. Second query is nothing but 4 comma 5, and third one that indicates that we are having only one number, nothing but here we have the number 8, right? So the output that we need to get here is, for the first query we need to get the output 3, for the second query we need to get the output 1, and for the third query we need to get the output 0. Means for 1 comma 4 comma 7, for this one we need to get the output 3, right? So the output that we need to get here for this one is 3. For 4 comma 5 we need to get the output 1, and for the this one 8 we need to get the output 0. We need to get the output 0, right? So here, this is it for the question part. So this is mainly for the question part, right? So this is it for the question part. So just keep this in mind. So let me delete this one entirely, man. Let me delete this one entirely. And again, so this is segments, and this 3 is nothing but the query, number of segments and the queries, right? So number of queries. So 1 3 4 5 and 6 7 are the segments. So first number here, in the query represents how many numbers are present. So here 3 indicates that we have three numbers, 147. 2 indicates that we have two numbers, 4 5, and 1 indicates that we have the number, uh, we have 8, right? So we have one number 8. So I hope this is fine, man. For 147 we have to get the first query, we have to get the output 3. For second query we have to get the output 1, and for the third query we have to get the output 0. So we will be considering the first query, and you can do the same thing for the second and third query within the approach. So I'll be considering this one. So segments, we have to consider all the segments, right? Segments, this is fine. So for the query, so I'll just show for the first query within the approach 147. You can just consider for 4 5 and 8. You can consider for 4 5 and 8, right? So just keep this in mind. So let me delete this one. Yeah, uh, let's discuss the approach first, as we are completely familiar with the this one question and the input output part. Let's move on with the approach part. Let's discuss the approach followed by the complexities, and then let's write the code. As usual, initially let's discuss the approach first. So here I have considered the same first example that they have given in the question, right? So this one we have already discussed. So 3 3, this one I'm speaking of, right? So we have three queries and three segments. So this is nothing but first query, first segment, sorry, first segment, second segment, third segment. These are the three queries. So this is first query 147, second one, third one. So this has to be 8 man. Just now we have discussed, I have written 0, sorry. So output that we need for, we have to get for the first query 3, second query 1, and output that we need to get for the third query is, this one 0, right? Let's move on with the step-by-step explanation here. The segments we have got here is 1 3 4 5 6 7, and the query 1 consists of 147, query 2 consists of 4 5, and query 3 consists of 8, where the output that we need to get here is 310. Same thing, right? So here we'll not be going with a direct solution. Instead, we'll be going with the inversion, right? So instead of checking with the segments that contain a query point which is big of n into m, right? So instead of checking which segment contain a query point which is big of n into m, we will invert the problem. So again, as I've said, we'll be going with the inversion logic rather than solving it directly, right? So we will invert the problem. So when I say we invert the problem, we will find how many segments do not contain any point from the query. So we have to find how many segments contain any number of points from the query, right? Instead, we will be going with the instead we will invert the problem, right? So instead we'll invert the problem, and let's find how many segments do not contain any point from the query, so this is the inversion logic we'll be going with. So for the each query, we will find the gap between the points. We have to find the gap between the points, right, for each query. So we have the query 147, we have the query, the second query is which consists of the two numbers 4 and 5, I think. Yeah, 4, 5 and 8. The third query is 8, right? So for the first query, or for each query, we will find the gap between the points, right? So just keep this in mind. Any segment that entirely lying inside those gaps is the segment that does not intersect the query. Again, any segment entirely lying inside those gaps is a segment that does not intersect the query. So the points we have here is 1, 3, 4, 5, 6, 7, right? So we have the points 1, 3, 4, 5, 6, 7, and these are the queries, right? So these are the queries and these are the segments. So so we have three segments here, right? Any segment that entirely lying inside those gaps is a segment that does not intersect the query. So this one, that does not intersect the query. Just keep this in mind. These words are important, right? So again, this part is very important. So any segment entirely lying inside those gaps is a segment that does not intersect the query. Right, so let's go with the final answer here. Total segments minus segments that fall entirely within the gaps, right? So total segments minus segments that fall entirely within the gaps. So first we will be going with the total segments. Total segments we have is 3, and the segments that fall entirely within the gaps, that we need to find, right? So total segments we have been given in the input 3, nothing but 1, 3, 4, 5, this one. 1, 3, 4, 5 and 6, 7, three segments we have, right? So let's see how it works. So we have first query is 147, we have, this is the query 1, right? So gaps we have here as 2 comma 3, 5 comma 6, and this one, what do we call, 8 comma infinity, 8 comma infinity, right? So this is the gaps basically we are having. So what we need to find, we need to count the segments that fall completely within these gaps, and we will subtract that one from the total. So let's move on with the further things here. So we have the segments. So segments is already given in the input 1, 3, 4, 5, 6, 7. So here these gaps, we whatever the gaps we have here, 2 comma 3, 5 comma 6, within this one we have 2 comma 3 we don't have, right? So again, for after 4 we don't have 5 comma 6, these are the gaps. So don't get confused with the gaps, right? So we don't have this one, what do we call, uh, 1 we have, and after 1 we don't have the numbers 2 comma 3, so this is one gap, right? So this is one gap, so this we have considered here. After the number 4 we don't have 5, 6, so that is the gap we have considered. After 7 we will be considering the next number, because see here, just give me a second here. So we have 8 here, we have the 8 here, right? So we have the number 8 within the query, so it ends at 8, it ends at 8. So we are considering the first query here, we are considering the only first query. So we have the 8, so here within this one, within this query we don't have the number 8, so 8 comma infinity will be considering, 8 comma infinity will be considering. So these are the gaps basically. So we have to check whether accordingly with this statement we are going, right? So we have to first of all, final answer is total segments minus segments that fall entirely within the gaps, entirely within the gaps. So as we need to find the segments that fall entirely within the gaps, we will be going with, I mean, we have to count the segments that fall completely within these gaps, and we have to subtract them from the total. See, uh, 2, this one, 2, 3, 5, 6, and 8 and infinity, none of them fully lie in the gaps. None of them fully lie in the gaps. See, 2, 3 we have, but 3 is already present, right? 5, 6 we have, 5 is already present, and 8 comma infinity we don't have at all. So none of them fully lie in the gaps, none of them fully lie in the gaps. So all three intersect query points, all three basically intersect the query point. So the answer we got here is 0, 0, right? 0, right? So final answer is, we have to go with the total segments minus segments that fall entirely within the gaps. So segments that fall entirely within the gaps, this one we got 0, we got 0. So we have to go with the total number of queries is nothing but 3, we know this one. We have to go with 3 minus 0 we got here, 3 minus 0 is nothing but 3, right? So the output that we got here is 3. So the output that we got here is 3. I hope the solution is completely clear, and for this we will be making use of one more thing. For this one we'll be making use of the Fenwick tree. As we need updation here, we will be going with a Fenwick tree for sure, right? So we'll be going with a binary index tree, right? So how we will make use of the Fenwick tree or the binary index tree, that we will be seeing directly within the code itself, right? So this is the approach basically we'll be going with, man. This is the approach that we'll be basically going with, right? So just give me a second here. Right, so I hope this part is completely clear. So the output that we got here is 3, and which is equivalent to the output that they have given for the this one, given for the query 1 within the question. Query 1 within the example 1, that is within the question, right? So here I insist you to try out for the same thing for the query 2 and 3. So we have the numbers 4 and 5 and we have the numbers 8, right? So here we need to get the output 1 and 0. I insist you to try out the same thing with the example, this one, the query 2 and 3, as I showed for the example 1, right? So the output is equivalent, the output that we got is 3, which is equivalent to the first output that they have given for the first query within the example 1, right? So our approach works absolutely correct, right? So our approach works absolutely correct. So as we are completely familiar with the approach, let's move on with the complexities part. So what would be the time complexity here? So the time complexity would be big of n plus m log m plus q log max, right? So the time complexity would be big of n plus m log m plus q log max. So this q, whatever I have written, this q is nothing but here this one, total number of gap queries. So while discussing the question, in the constraint I have said, this one, the constraint consists of this one. The total number of queries has to be less than total queries has to be less than or equal to 3 into 10 to the power of 5, right? So this is nothing but q is nothing but the total number of gap queries, which has to be less than or equal to 10 to the this one 3 5, for the sorting purpose. So we will be going with the sorting, and also we will be going with the this one bit, right? So bit, because binary index tree or the Fenwick tree, because we will be going with the update or queries. So queries they have given, so we have to go with the update operation, right? So we have to go with the update operation. So here we cannot make use of the sparse table as we have the update. Only when we don't have the update, so we can go with the sparse table or segment tree, right? So we can either go with the segment tree or the update, this one, Fenwick tree for this particular problem. So I'll be going with the Fenwick tree, bit. So code, the length of the code will be little bit small compared to the segment tree, right? So I'll be going with the Fenwick tree for this particular problem. So here the time complexity, the overall time complexity would be big of n log n plus m log m plus q log max, right? So I hope this is completely clear. Q is nothing but the total number of gap queries, that is less than or equal to 3 if I, just for the sorting purpose. Also, we are going with the bit updates and queries, right? So, and what would be the space complexity here? The space complexity would be big of n plus q plus max. So when I say n plus q plus max, so we will be going, or we will be doing sorting, right? So we'll be going with the sorting basically. So we have to sort the segments. Also we will be going with the gaps, and we'll be going with a bit array as well. As we are going with a binary index tree, we'll be considering bit array and answers. So overall space complexity would lead to big of n plus q plus this one max, right? So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n plus m log m plus q log max and big of n plus q plus max, right? So this one I'm speaking of, right? So I hope the complexities part is completely clear along with the this one approach, right? So as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code. So let's start writing the code. So just come here. So first we'll be making use of the different this one utilities as well as the fast input and fast output. So I'll just import input output package, so along with the utility package. So I'll just go with import Java. So this is fine. So the next thing, let's go with the class name here. Let me give main. So you can just consider question name itself or any relevant name. for this particular problem. I'll just go with the name main here. So as I've said, we'll be going with the Fenwick tree or the binary index tree, BIT. So why we are making use of the binary index tree here? So we have to go with the efficient this one range sum query, and also we have to go with the point updates, right? So that is the reason. So whenever there is update, so either we have to go with the this one, either we can go with the segment tree or Fenwick tree if we are considering the this one for the point updates, right? So we have to go with the range sum query and the point updates efficiently, so we'll be making use of the BIT for this, right? So let me go with static class BIT. So within this class, what I'll do, so let me go with int BIT. Let me initialize certain things here, also n, right? So this is fine. So let me go with the initialization part. So BIT I have considered, right? Sorry, this has to be capital itself. Class name I am giving here. So parameter, let me pass n, nothing but this acts as constructor man, basically initialization. So this will be this dot n. Let me initialize this one to n plus 2, and also pit this one, let me consider int of this dot n, right? So this is fine, I guess. There's nothing but the initialization part, right? So now let's move on with the point update part. Means we have to add the value at index I, right? So if you would have guessed update method, you are right. So we'll be going with the update method here. So we have to add the value at index I, right? So I'll just go with void update. So the parameters I'll be going with here as I and value. So we have to update the value at index I, right? So the parameters will be quite obviously I and value. So this is fine. So within the update method, so I'll just go with the while condition here. So while I less than n, what we will do? So bit of I equals bit of I plus val. So this is fine. This one I equals plus I and I. So this is fine. Minus I. Let me come out of this one entirely. So let's go with a prefix sum query from 1 to I. Let's go with a prefix sum query from 1 to I. So I'll just go with the query. This one, let me consider the parameter I, right? So let me initialize sum to 0 within the query method. So we have to return the sum, right? So we have to sum. That is the reason we are going with a query method, basically prefix sum query. So the name itself indicates that this is the prefix sum query from 1 to I. So I have initialized sum to 0. At last we have to return the sum. So I'll just write the simple while condition because I has to be greater than 0 every time. Then only we can move forward with the further steps, right? So I'll just go with I greater than 0. So this one will be sum equals sum plus bit of I. So this is fine. And I equals I minus I and minus. So this is fine, man. It's fine. So let me return the sum. Let me return the sum. This is fine. So let me come out of this one entirely. Now let's go with a range sum query from L to R. So let me go with a range query. So this one will be intel comma int r. So this is fine. So we have to return we have written query already, right? Query of this one r, nothing but right. So this one has to be query of this one l minus 1. So this is fine. So we are done with the range query method. So let me come out of this one entirely. So basically we are done with the this one custom Fenwick tree or the binary index tree class, right? So now let's move on with the main method. Let's move on with the main method, right? So here let me give main. Yeah, this is fine. Just give me a second here. Let me delete this one, not required. So here, as I've said, we'll be making use of the fast reader and the fast input and the output, right? So for the fast input, we'll be going with the fast reader. So I'll just go with the fast reader, or you can just go with the buffered reader as well. So this is fine. Fast reader. So input equals new fast reader. This is fine. And also, let me go with the print writer. So this one output equals new print writer. So this one will be system dot out. So this is fine. So let's move on with the further step. So we have to go with the number of segments and we have to go with the number of queries. Means we have to we have to go with the number of segments and queries, right? So this is the input output part. So initially we have been given this one 3 3 first line of the input. So see here, this one 3 3 we have to go that is nothing but the number of segments and number of queries, right? So I'll just give here int n equals next, and so this is fine. The next part is we have to go with the number of queries. Let me copy the same thing here and let me paste it over here, right? So instead of n, I'll just make this m. That is nothing but n and m, right? So this is fine. We are done with the first part. So next we have to go with the max coordinate on the axis, right? So let me initialize max according to the question they have given. So they have given 3 into 10 to the power of 5. So let me go with the value 1 5 times 0 5, right? So this is fine. To what happened here, yeah, 5 times I've given, right? So yeah, this is fine, man. So we are just going with a max coordinate on the axis, so this is fine. The next step is let me go with the variable segments and let me initialize with int. This is nothing but n and 2 within the array. So we have to read n segments. For reading n segments, let me move on with the iteration part. So this will be I equals 0, I less than n. So this will be I plus plus. So let's go with the segment. So this one is L and R, nothing but the left and right. So let's go with the segments. This one will be I, this one will be 0 and n dot next end. This is fine. Again, this one will be segments, this one will be I, this one will be 1, and this will be dot next end. So this is fine as well, man. Let me come out of this one entirely. So let's go with the array list. Let's go with the array list. So I'll just go with list. But on this, I'll be making use of the integer. So let me go with the variable name gaps here. So we have to consider the gaps, right? So this will be, we'll be considering array list here. Just the syntax part. We're going with the instance of array list. This is fine. So for each query, we have to compute the gaps, right? So for each query, we have to calculate the gaps between the consecutive points accordingly with the question I'm speaking, right? So for each query, we have to compute the gaps between the consecutive points. So I'll just go with the for loop here. This one int I equals 0, I less than m, right? So queries we are speaking of, so I'm considering m here. So within the for loop, what we have to do, we have to go with the number of points in the query, nothing but k, right? So k, let me assign this one to the, again, next int. In is nothing but the input. Next int we have already considered. So this one, right? So previous, let me initialize this one to 0 and let me go with the for loop. This is nothing but int j equals 0, j less than k, j plus plus. So this is fine. So within the for loop, so let me go with the for loop. So within the for loop, let me initialize x equals same thing, input dot next int. So this we know, man, it's related to the input output. This is fine. So let me write the simple if condition. Let me finish it. So I finish it off this one very quickly. So this one will be previous plus 1 less than or equal to x minus 1. Then what shall I do? So we have to add the gap, basically nothing but previous plus 1 comma x minus 1. So this one I'll just go with add property here, new int. So this is fine. So we'll be going with a previous plus 1 comma x minus 1 also I. So after adding the gap, so let me assign the previous to x. So this one will be x. So this is fine, man. Let me come out of this one. So we have to add the gap after last point to max as well. Initially, in the previous step, we have added the gap previous plus 1 comma x minus 1, right? So now we have to add the gap after last point to the max. So I'll just go with a one more if condition here. Previous plus 1. So this, if it is less than or equal to max, right? So then we have to add the gap of the last point to max again. So let me copy the same thing and make the necessary changes here. So I shouldn't have copied, I should have typed. So this is fine, man. Gap start or new, so this one will be fine. Previous, so here let me remove this one. Typo. Just give me a second here. Let me remove one flower bracket here. The same thing. So this one has to be new int. Yeah, previous plus 1 remains same. Instead of the x minus 1, we'll be going with a max here. This one will be max and this I remains same. So in the previous step, we were just adding the gap, nothing but previous plus 1 comma x minus 1. Here we are adding the gap after last point to max. So we have to consider max, right? So here, this one, whatever I have considered max here. Instead of x minus 1, we'll be going with a max. That's it. That is the difference, right? So let me come out of this one entirely. So what we need to do now, we have to sort the segments and gaps by starting point and decreasing order, right? So again, what we need to do here, we have to sort the segments and gaps by sorting point on the descending order. So let me go with arrays dot sort. uh, Let me go with the segments, comma a comma b. This is fine. uh, this one is lambda expression, so this is fine. Integer dot, so let me go with compare keyword. So what we need to do here, we are sorting the segments and gaps by starting point in a decreasing order, right? So in the decreasing order means we have to go with the b of 0 comma a of 0, as we are going with a decreasing order. So this is fine, man. B of 0, a of 0, b of 0 comma a of 0. So this is fine. So somewhere I have done something wrong, man. I don't know what I have done wrong. Somewhere I have done something wrong. Just give me a second here. Segments I have considered, so this is fine. Yeah, I have considered one more this thing here, bracket. So let me delete one parenthesis here. This is not required. So this is fine. uh Now, gaps, with gaps also we have to do the same thing. So this will be gaps dot sort. So this one will be a comma b. Same thing, integer dot compare. So this one also we have to sort in the descending order. So this one will be b comma 0 comma a of b of 0 comma a of 0, right? So this is fine, man. The next part is we have to go with the Fenwick tree to track the right ends of segments. We have already written the Fenwick tree or the BIT, right? So let's uh, let's create the instance of the BIT, man, here. So in simple terms, so we'll just go with BIT here. New BIT of max. So this is fine. So this is just the Fenwick tree to track right ends of segments. Next, we have to store counts of segments that do not touch the query. So for that one, I'll be considering the variable answer. This is just uh, nothing but the answer here. So I'll just go with new long of m. So this is fine. So the next one is in index. Let me initialize this one to 0. So this is fine. For each gap, we have to count how many segments lie completely in it, right? So let's go with a for loop here. For in gap of gaps. So this is fine. So within the for loop, so what we'll be doing, we'll be uh, going with a L comma R, right? So L comma R, basically it is the gap for the query QID. So I'll just go with int L equals gap of 0. So R equals gap of this one is 1. Finally QID, let me initialize this one to gap of 2. So this is fine. So L comma R is the gap for the query QID. So this is fine. So the next step would be we have to insert all the segments with L greater than or equal to Li greater than or equal to L into the binary index tree. Means right ends Ri into the bit, right? So right ends Ri into the bit. So let's write simple while loop here, because index has to be always less than n, and the segment of index 0 has to be greater than or equal to L every time. Just to insert Ri into the bit, these two conditions has to be always true, right? So let me write the simple while loop here. So this one, index less than n and segments, so this one will be index 0 is greater than or equal to L. So this is fine. So now we have to insert Ri into the bit. So this is nothing but I have considered bit already. So we have written the update method already. Let me come here somewhere. Update first method itself is the update, right? So let me copy this one method. Let me paste it over here. Bit.update. So this one will be again segments. Mm, Index nothing but idx, so this will be 1 and comma 1. What we are doing, we are just inserting Ri into the bit right side. So right index, this is fine. We have to increment the, we have to go to the next index, nothing but we have to increment the index. So we are done with this part. So let me come out of the while condition. Now we have to query how many Ri is less than or equal to R, nothing but segments where Li is greater than or equal to L and Ri is less than or equal to R. So I'll just go with answer here. Answer, so I'll just go with QID. This one equals bit dot, this will be range query. Where is range query? Let me copy this method. So we have already performed the range query, right? So I'll just copy paste this one, paste the range query here of the parameters. So parameters, it consists of as L and R. So we'll just give L and R here. So this is fine. Let me come out of this one entirely. So final answer is total segments minus segments that fall in the gaps, right? So accordingly with the approach we are going. So whatever we have discussed in the approach, that itself we are articulating in the form of code, except this one. So data structures we didn't go deeply when we discuss the approach, basically the segment tree part, this one, the Fenwick tree part and other stuff, right? Except the approach remains same. Approach remains same. So same thing we are articulating in the form of code. That's it, right? So final answer equals, so total segments minus segments that fall in the gap. So that's what we saw in the approach. So let me go with the for loop for the this one iteration part. So a individual a answer, so we have to print. So I'll just go with the println. So let me go with the println. This is fine. So this will be n minus a. Finally, we have come to the last part, nothing but we have to flush the output. Either you can go with out.flush or out.close. I'll just go with the out.flush. So this is fine. So we are left with the only one thing. So here, if you observe somewhere, we are left with the input output, but we are done with the logical part. Logical part, this is it. This is the logic basically we are going with. So final answer we have got. So one thing somewhere, where is the input output part? Man, just give me a second here. This one. So here I have made use of the fast trader, right? So fast trader. So this fast trader, let's write the this one custom fast trader method for making use of the fast trader. Print writer, this is built in, right? So we are making use of the system.out. So here fast trader, we will be writing the custom fast reader. So this is related to the input output. Basically, this is related to the fast input, right? So now I'm not gonna type this one. I'll just paste this one, right? So fast reader method. So let me come here 1 second. Yeah. So let me delete this one as well. So let me paste it over here. So this is nothing but the fast reader method, right? So custom fast reader, we are going with a custom fast this one cast fast input. Basically the name we are making use of here is fast reader. That's it, right? So we are done with the code. That's it, we are done with the code. This is just you can just take the template one. I make use of many templates basically accordingly with the question, right? So accordingly with the question I go with different templates. Basically this is one of the templates I make use of, so you can just go with any templates, right? So this is just nothing but it is related to the input output part. So we're done with the code basically, right? This is it for the code. Before checking the code with the different inputs, let me do one thing. um, I'll just copy paste the signature starter template, right? So then after that we can just check the code with different inputs. Just give me a second here. So let me come here, let me paste the signature starter template here. This is fine. Let's concentrate on the logical part. I'll just come here, let me copy this one. So the output that we need to get here is 310. Let's check whether the code works correctly or not. So we are having some errors, two errors here. Previous, this one, line number 75. Where is it? Just give me a second here. This one has to be previous plus one less than or equal to this one, right? Or it's just previous plus this one. Where is line number 75? What we are doing here? Just give me a second here. This is within the main method, right? So we are going with a if condition. Just give me a second here. Yeah, this has to be previous plus 1 less than or equal to x minus 1. Uh, Let me run this one. Yeah, yeah, one error is gone. So now illegal start of the type. What is illegal here? Line number 28. We don't do any illegal things. So see here, this one is public int n. So public, so this one bit name itself I have not given here, right? So this one has to be bit. So this is nothing but the constructor part, initialization part. So let me copy this one and paste it over here. Wait, intent. So this is fine. Let me run this one again, man. Oh, actually we have many errors. Uh, Error cannot find the symbol. IDX. I haven't initialized IDX anywhere. Where is it? Line number 96. 96, 96. While IDX, this one. Oh, index I have given here. This one has to be IDX. Have initialized wrong here. This is fine. Let me run this one again. So yeah, we are getting the correct output now, 310. So this one initialization part was wrong basically. Instead of the IDX, I had given index. So that is the reason it was giving this one error. Cannot find the symbol IDX. So this is fine. Now we are getting the correct answer, right? So we have to get the output 310. So only one this one they have given, only one example that they have given that consists of the number of segments and number of queries, right? So it works correctly for all the inputs that they have given in the question, our code. So let me copy this one. Let's submit the code. I'll just hit the submit button here. So this is E, right? So let me select E, the last one, Valera and the queries. So let me paste the solution and let me hit the submit button. I hope this works for all the test cases, man. Let's see. Let's wait for some time. Yeah. we are strictly going with a this one, Finvictory along with the sorting. We are sorting in the decreasing order, this one, right? Segments. So this one we have seen in the approach as well. Yeah, you can clearly see here, and the toast it is showing accepted, right? So the verdict that we are getting here is accepted. So this is fine. So yeah, purely we are going with a basically segment tree and the this one Fenwick tree or the binary index tree with a sorting for this particular problem. So the verdict that we got here is accepted, means our code, whatever the code that we have written, works absolutely correct for all the test cases, man. Yeah, the code works absolutely correct for all the test cases, right? So now I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.